Hello, in this video I'm going to modify my FlySky radio to change one of these variable position dials here, and I want to replace that with a set of these little buttons so that I can use these buttons to select flight modes in ArduPilot. So I'll probably put 6 buttons up there, but you could use more, I think. And the way that ArduPilot's flight mode selection works is you have one channel selected, so in this example image here it will be channel 5, and whatever the value or the PWM value of that channel is at the current time, for example if it falls into the range of 1231 to 1360, you would be in flight mode 2, which in this example is set to stabilize. And in theory you could use this dial to select those flight modes like that because it's smoothly variable and you can put it in whatever position you want, but obviously that's quite tricky to get it in the right place every time. So of course we use switches to do this, where the switch is going to immediately jump between a set of fixed positions and get it just right each time. The trouble with a lot of radios, and this one is no exception, is that often the highest number of positions of the switch that you have is 3, as is the case here. And what I typically do is I lose 2 of these positions because I want to have one that's always going to be manual, just in case I get into a situation, admittedly very rare, but I have had just once so far a situation where the plane tip stalled. Yes, I'm looking at you, Skywalker Falcon. And I was in fly-by-wire A, and fly-by-wire A didn't know how to get out of the tip stall, and obviously return to home wouldn't have been much better, I don't think. Anyway, so I'll have one mode for manual, one position for manual, and then another position for return to home, and that's sort of, I'm not sure if I need to do that as a fail-safe setting, but I always like to have it anyway, just in case it goes out of sight and behind a tree or something, and I'm like, oh shit, I can't see it, so I'll just use return to home, return to home to make it come back. Anyway, so that leaves me with just this one position in the middle to do what I really wanted to do with the plane, which was usually fly-by-wire A, but sometimes it's auto, and I have had quite often I just want to do something like take off my jacket or find a nicer place to sit down or something like that, when I don't want to keep my eyes on the plane constantly. Usually what I'll have to do is put it into return to home to do that, which can be a bit of a nuisance if I'm flying out further away and I didn't really want to return to home. All I wanted to do was have it to loiter there for a bit. So I'd like to have loiter and also auto, and basically just this one mode in the middle is kind of inadequate. Now I know that you can use second switch or other channels to set up a mix in the radio, and I think the Tyrannus does a much better job of this, and a lot of other radios do, but this one all you can do is offset this channel a little bit using a second switch. So I think I tried this a while ago and I must have done something wrong because I could only get 4 modes instead of the 3, but now that I look at this again I should have been able to get 5, because let's suppose you offset this first channel by 241 or 240ish. That would change flight mode 1 to be flight mode 2 because you'd be at 1240, right? And then flight mode 4 would be offset 240, it would be 1740, so you should be just within this range. So you should be able to get flight modes 1, 2, 4, 5 and 6 with a second channel mix set up like that. But of course you're losing another channel to do that, right? So overall it's nicer if you could just do this with one channel. And another thing that I don't like too much about having everything on a single switch channel like this is that you need to pass through the modes in between to get to where you're going. So if I'm in manual and I wanted to go to return to home, I have to pass through the middle position, which might be auto or fly-by-wire A or whatever it is. I have to go into that mode just briefly to get through to the other side. And in some situations you might not want to do this, particularly if this was auto mode and you had a mission where there were some commands at the beginning of your mission that you didn't really want to run until you were actually ready to start the mission. For example, do set home or something like that, or what's some of the wait commands or something like that. You might not want to have those running until you're actually ready to start the mission. So skipping through them, or you're not skipping, you're actually going into that mode briefly to get to return to home. That's not really ideal, whereas what I'm hoping my buttons will do is that they will just instantaneously go to that mode without passing through any other modes. So how is this going to work? We need to replace a physical analog potentiometer like this with one of these things here, which is a digital potentiometer. So basically we need to have an Arduino that's going to detect button presses, and this Arduino will remember which button was pressed last, and it will tell this variable potentiometer to send the right resistance to the radio. So the radio is not even going to know that any of this is going on, I hope, but this will achieve what I'm trying to do. So let's have a look at the datasheet for these little things and we'll see a little bit more about them. This is the item here. I got it from JCar Electronics. They actually do online shopping, so I didn't have to go into the shop or anything. I just bought it and they delivered it to you. It's quite nice. It's about $5 New Zealand, which is about $3.50 US, I think. And it is a 257-step digital potentiometer, and it's an MCP4151. And just looking at this now, I think I might have made a bit of an oopsie here, because it's a 10 kilo ohm range instead of 5K, which I thought I was getting, but I think it should still work. And here's the datasheet for that. There's a nice little diagram here which explains things quite clearly. This is all I really wanted to look at for now. So we can see that it's an SPI interface, as it shows there, and we have chip select not clock, then we have the data line, only one, looks like it's clocking out on the same line there. Then we have a ground and a power, and so this 5, 6 and 7 pins here are the outputs of this that are going to replace the potentiometer and the radio. So we're going to have one of them will be ground and the other will be VDD again, and then this wiper is what the radio is going to be looking at to decide where the position of that channel is. So it's sort of signified by a variable potentiometer signal in there, and we can send some information here on the SPI lines to say whether this, so W is wiper, whether this wiper should be closer to the B or to the A. Now, as it happens, this particular radio here has already had some modifications made to these dials. They're not actually connected. The wires that were going to those dials have been taken out the back here, and I was using this for a dual operator setup where one person could use the radio to fly the hexacopter and another person would be controlling a second joystick connected to these here to direct the camera direction, and that worked pretty well. We didn't have any incidents with it, but it was a bit of a nuisance that had to be sort of chained together with this wired connection. So I think in future, if I do that kind of thing, I'll just make it use a second radio and a second receiver so that the second operator can just stand wherever they like to control the camera. Anyway, there's two sets of wires coming out here. They don't seem to want to focus for some reason, but yellow one is ground, white one is positive 3.3 volts, and the middle one is the wiper connection that we're going to have to feed back the potentiometer position. Now this being 3.3 volts here, what I'm going to try and do is run my Arduino off that, and even though I'm using a what we typically call a 5 volt Arduino, if you power it from the VCC pin there, you can use 3.3 volts. I did a quick little test before, and it powers up, at least it runs the blink sketch, so it looks good at this point, but I'm not really sure if it's actually going to work fully for this project, but we shall find out. This corner here with the little dot on it, I'm pretty sure that's pin number 1 there, so I'm just going to connect this up according to the diagram that we just looked at. Just checking the datasheet again, this 4151 that I'm using is safe to operate up to 5.5 volts, so I can use it with my 5 volt Arduino in the normal way with my USB connection and it should be fine. Okay, I have everything connected up there, and I'm using pin 9 as the chip select for my SPI interface, which is why I have chip select 9 defined here in my sketch. So I just have a little sketch here as a test to see that this thing is connected up and it works properly. And I won't pretend that I figured this out from the datasheet. I will instead point you to a very good video that covers this in the link in the description. And basically we just need to do an output definition for that pin, SPI begin, and I've set up a little function here that will help us to set the chip select pin low and then higher afterwards when we send a value to the digital potentiometer. My connections here for the ohm meter, so I'm measuring ohms here, kilo ohms there it's showing. At the moment I have this connected to the pins A and B on each end of the wiper range. So this is the full range of the resistance that we're going to see. It's a little bit concerning that it's changing so much. I don't like that. It was under 9K just before. Now possibly the reason that it's changing is because I'm sending various values to it. So I have a loop here, and every 3 seconds it's changing the value that the potentiometer should be. So it's going from 0 to 64 up to 255. So remember that this is a single byte value, so the highest value is going to be 255, and this 64 will be sort of like a quarter of that. So if I change my pin that I'm sensing on to be the middle of the potentiometer, we'll see 120 ohms, 2.5k, 4.8k, about 5k, 7k, and then 9.2. So that last one should be the full range that we saw before, and every 3 seconds it's just switching between those. I am a little bit concerned that the values, I was going to say they're slow to adjust and they keep changing, but not always, and it could be partially because of this multimeter is sort of doing an automatic range finding thing all the time to select the units. So sometimes it's showing you kiloohms and sometimes it's showing you just ohms, and it's constantly trying to find the best range. So yeah, but all the same, I don't like the fact that it's just sort of not very steady. Okay, so next thing to do now is I'll hook this up to the back of the radio and see what this looks like on the display screen on the radio. Okay, so now I have A, B and W of the digital potentiometer connected up to the back of this, and just a little bit of tape to stop them touching, hopefully. And if we look back around here, I have selected variable resistor A to be my channel 9. Whoops. So we're looking at channel 9 here, and we should see every 3 seconds it's changing. Why doesn't this want to focus today? There we go. Alright, so channel 9 is changing all by itself. That's what we wanted, and it's going approximately in quarters, so a little bit below the middle there. Oh damn it. But it's working, and now it doesn't look so unstable anymore. It's snapping to that value very quickly. Okay, now I've modified that sketch a little bit to use some inputs to detect button presses. So I have my buttons on pins 2 to 7 like that, and the resistances that we want to have for each of those modes are going to be these. So that's 75 out of 255 is approximately what we want to get to 1296 microseconds for the PWM, and I got these values by looking at the middle range of, for example, 1231 to 1360. The halfway point of that one is about 1296. So you take 0.296 multiplied by 255, you should get about 75. So that's where those numbers came from. And at the beginning of the sketch we set all of those button pins to be inputs, and then down here in the loop we check all of those button pins to see if, we're just going to use digital read because that's fine for this purpose, and if it's high we'll set that to be the active button index, and then every loop we're just going to update the digital potentiometer with the current value of the resistance that it should be using. Now this is not the end of the story, because these pins are all floating here. They should have a pull down resistor to ground, but they don't have them at the moment. So you can see, oh no, you can't see because I have this in the way. You can see channel 9. Oh, it's not doing anything right now, but if I sort of move, let me touch pin 2. So it's going to fully down on pin 2. It seems to stay there quite nicely, and if I touch pin 7, it goes up as well. But anywhere in between, it doesn't want to stick in one place. So let me touch pin 4, and it's a bit hard to see in the video maybe, but it's sort of flickering around and it doesn't want to. Look at that. It's, oh, if I move my hands around it like this, look, I can get it to change just like that. Anyway, so this is not ideal. So what I need to do now is have a pull down resistor to ground for each of those 6 pins there. Actually, I just remembered that these Arduinos have internal pull-ups available, so if you configure your input pins to be input pull-up, which I have just done here, input pull-up like that, then instead of pulling it high to detect a button press will pull it low, and that's a lot easier. So that's what I've done here. So now my piece of wire that I'm touching on the pins is going to ground instead of to positive voltage, and this works quite nicely. So I can touch my fingers on here, nothing changes, and if I touch it to pin 2, we should get fully down. Pin 3, pin 4, pin 5, and pin 6 and 7. Now I wasn't watching there, but hopefully that was moving steadily upwards. So that's quite nicely working, I think. But still not the end of the story, because these values that we're passing here, we really need to check that they're actually coming into ArduPilot in the ranges that we wanted them to. So next thing I should do is connect this up to a flight controller and use the mission planner to check what values are actually coming out of here, and maybe they might need a little bit of adjusting. Okay, so now we're looking at the mission planner radio calibration screen, and you can see the roll value changing left to right as I move the sticks there, and I've changed the flight mode control channel to channel 5 here, and you can see it's on 1313 because my plug is in channel button 2, so we wanted that to be within the range 1231 to 1360, ideally 1296 as we had said before. So 1313 is a little bit off. Let's see what we get for channel, well, mode 3. 1442 is within the range. So it looks like these are probably going to work. That's position 5, 1560. So I'm looking I'm looking at this value here, 1565. Is it within that value? Yes. What else do we have? Mode 6. So we got 1692, looks alright, and then the last one should be 2000-ish, well, 1993. So it would work as is with these settings, but I think I'll tweak it a little bit more so I can get it a little bit closer to my ideal values here. Alright, so after a bit of twiddling around, I came up with these numbers here. I didn't actually need to change them that much, and I made this little test button bar to check that the whole thing was going to work with the buttons as well, just to make sure there was no surprises with these. And so I've got mode 2, so I'm looking here, mode 3, mode 4, 5, 6, and I can jump from 6 to say 2 immediately, and I don't think that it's going to skip to any of the other modes along the way. So let's, oops, I'm looking at this over the wireless network, so it's a bit slow. Well, it turned out to be far too slow to use remote desktop to look at the data coming over the USB line to do that check. So what I did was I got the data from the onboard SD card, the black box SD card, which is a lot quicker, and I'm just looking at a screenshot of that here. So what I've done is switch between some modes here, and you can see the modes labeled at the bottom, and you'll see that I was able to go from manual to RTL without going through fly-by-wire, which is in the middle of these two. I'm a little bit puzzled as to why there are two titles here for this one. Not too happy about that, but there's no fly-by-wire showing up at least. So it looks like what I've done does let you skip directly from one mode to another without going through any in-between. Having said that though, I didn't actually check what happens when you do this, when you just flip the switch quickly with the normal switch. It may be that the ArduPilot people have thought about this and they have made it not switch into those modes along the way if you do it very quickly. I don't know. But in any case, this seems to be working fine. So I think I'll just leave it there for this video. All that remains is to tidy this up, maybe put it on a proto board or something and mount it up here, and probably just take these pots right out so that this is a little bit flatter and sort of put it on there somehow. And I'll also have to figure out somewhere inside here to get that 3.3 volt power from, because you cannot use these same wires for power, because what you're going to be doing is putting a resistor between them with your digital potentiometer. So you're going to need other wires or another location on the PCB in here to get your 3.3 volts from. That shouldn't be too hard, and I don't think there's anything to be gained from anybody watching me fumble my way through that. However, to be perfectly honest, as I sit here and look at this, I think it may be more of a hassle than it's worth to make this mod and get it all attached, just to have these buttons to press. So I'm not sure if I'm going to go through with this at this point, but anyway, it was interesting to see that it would work if you wanted to spend the extra hassle to get it all tidied up. That's the end of the video. Thanks for watching.